All right, I am back. Here we go. Okay, sorry about skipping 5 and 6. Not sure what happened, but here we go. So number 5, it says the equation P of W equals E to the W represents the population of a mold sample W weeks after it was initially counted. So this, because it's an exponential curve, we've got time here on the x-axis and then the population on the y-axis. Use the graph to answer the questions. What is the reasonable approximation for the natural log of 500? So if we look at this, the natural log of 500, so the natural log is going to mean that we used a base e, right? And so we know, like back here, we have e to the w. So this is really asking us for what value of w does e to the w equal 500. So here's the 500. It intersects right after 6 weeks. So I'd say w is about 6.2, and you can see it on the graph. So like I want to mark where that is on the graph to show that I understand how it works with the natural log and an exponential function with base e. And then what does the natural log of 1,000 represent in this situation? So again, if we look at this natural log of 1,000, so we'll be looking at e to the w equals 1,000. So what that means, what it represents in the situation, is the time in weeks for the mold population to reach 1,000. Okay, that's what that means in this situation. All right, and then number 6, we just have a bunch of equations to solve. Be sure to show your work, and I cannot stress that enough. You guys like to do a lot of stuff in your head. You need to write it on the paper as well. Okay, so here we go. We've got kind of the same strategy every time. Isolate the base and exponent, switch to log form, and then solve. Or you can also switch to powers with the same base, which I think is what we're going to do for A after we divide both sides by 9. Okay, so dividing by 9, I get 10 to the 2n is equal to 1,000. And this would be a great time to use powers with the same base because 1,000 is a power of 10. It's 10 to the third. So because their bases are the same, then their exponents have to be equal. So 2n equals 3. Divide by the 2. You get n is equal to 3 halves or 1.5. Okay. All right. Next, 4,500 equals 6 times 10 to the m. So divide by the 6 to get 10 to the m by itself. Let's see here. 4,500 divided by 6 is 750. So I have 10 to the m is equal to 750. 750 is not a power of 10, so I'm going to switch to log form. Bring the exponent down. It's a base 10, so I can just write the log of 750. And then I can find it on my calculator. Log of 750 is 2.875. So I'm going to round that to 2.88. Again, it doesn't say what to round to, so I'm just going to choose to round it to 2 places. All right, C. We need to isolate 2 to the k by dividing by the 7. And my calculator here, 112 divided by 7 is 16. So 2 to the k is equal to 16. I happen to know that 16 is equal to 2 to the 4th. And so again, if the bases are the same, the exponents have to be equal. K is equal to 4. If I didn't know that, I could have done the log base 2 of 16. And notice we also get 4 that way. Either strategy is fine. Just show your work. Show what strategy you're using. Don't just go 2 to the k equals 16, k equals 4. Like, show it. Show it in between. All right. Next, 4 to the x minus 7 is equal to 1024. I'm going to go ahead and switch this to log form by bringing down the exponent, the entire x minus 7. It's equal to the log base 4 of 1024. Now, if you're working with a calculator that doesn't have the log base option, remember you can still evaluate this by doing the log of 1024, close the parenthesis, and we always divide by the log of the base. So the log of the base always comes second, okay? And so, it's equal to 5. So that means 4 to the 5th. Oh yeah, we had that actually in an earlier problem. So this is equal to 5. So what that tells me is x minus 7 equals 5. So then we're going to add the 7, x equals 12. Okay. All right, our next one, 2.5. Okay, so here we've got 10 to the x plus 3. So that's our base and exponent. So we're going to divide by the 2.5. And 25,000 divided by 2.5, I think is 10,000. Yep, okay. So I get 10 to the x plus 3 is equal to 10,000. Again, 10,000 is a power of 10. It's 10 to the 3rd. So if the bases are the same, then the exponents must be equal. So if x plus 3 must be equal to 3, when you subtract 3, you get 0. So x equals 0. And finally, run the last one. So we've got a couple things going on here. Here's our base and exponent. It's being multiplied by 3 and then subtracted by 59. So we first will address the minus 59 by adding it. And so we get 3 times 7 to the 4m equals 4,740, plus 59, 4,800. Okay, now we need to divide this 4,800 by the 3. And so we get 7 to the 4m. 4,800 divided by 3 is 1,600. Okay, so we've got the base and exponent by itself. We're ready to switch to log form. Bring the exponent down. 4m equals the log base 7 of 1,600. And so m is equal to the log base 7 of 1600 divided by 4. And I'll put that in the calculator. Let's see here. So math. Okay, log base. Log base 7 of 1600 and then divide by 4. About 0.95. Write that here. M is about 0.95. All right, so that is the last of your review packet. All right, I hope this was helpful.